we have We've touched on the wave energy before. Here we, under coming attractions, we are looking at something very specific called solid state wave energy for obvious reasons. The potential for ocean energy is pretty massive. This is from an IRENA report which is showing ocean technology for generation of electricity, so various things like salinity gradient, tidal width, tidal power, wave energy, and so on. This is the ocean thermal energy conversion. Looking just at the wave, this amount of terawatt hours, 29,500 terawatt hours, or converted into terawatts, is several thousand times the amount of energy that the humanity uses. And this is constantly produced, as we talked about before. Wind energy is harvested by the ocean at just few percent because of the inefficiencies of converting the energy into dragging the ocean. But nonetheless, since the ocean is constantly churned, it does give us a massive amount of energy. Looking at active and projected tidal stream and wave capacity beyond 2020, though, the potential projected capacity is here for the wave here and tidal stream here, but the current capacity is just a tiny bit of what is potentially available. So this is something that is considered something that is exploitable, and yet anything you put in the ocean that has moving parts or not is subject to biofouling and other problems, salinity. So it's a massive problem. There's a storm coming, so you hear a lot of noise outside. The first pre-monsoon storm that I'm looking at. So examples of wave energy technologies, we've talked about oscillating water column before, invented by the Japanese scientist, overtopping device, attenuator, point absorber, and oscillating water surge converter, submerged pressure differential, bulge wave, rotating mass. All these have moving parts. What is especially highlighted here as a coming attraction is this device, which has rods inside anchored by this heavy concrete block, and the idea is to prevent the rods, which are wound with coils, so that when there is a tendency for the waves to lift it, the anchor, this concrete, holds it down, so the rods are just bent and compressed, and that compression is converted into those are basically magnetic rods. Those are converted into electricity, and you can see the associated wiring converting that energy into storage and so on. So theoretically, one can harvest many terawatt hours, maybe even thousands, if they can economically be done this way without having any moving parts. Of course, transporting it and so on are all still the big questions, plus just the economics of putting it offshore and using it. This intermittency problem can be removed by having proper storage and so on, but nonetheless it is an exciting idea that is considered here as a coming attraction. And we have seen this before. This is the mean wave energy available in kilowatts per meter. So we are looking basically at regions where the wave heights are substantial and the wave energy is massive. So the Southern Ocean, of course, always shows up because it's a channel where the ocean energy, gaining wind energy here is limited by these boundaries, so it only amounts to about 5% or less of the wind energy going into the ocean to generate the waves. And there are other reasons why wave energy is stronger here. The mid-latitude westerlies in both hemispheres, of course. In general, tropics have much weaker winds. And here the amount of energy going in is much higher because of this channel configuration. So you can see the difference here. This is order 75 here, and this is order 125, so more than 50% larger in terms of available wave energy. So whatever the technology, whether moving parts are made capable of withstanding the assault by salt and biology, and the transmission problem is solved, or it is the solid state wave energy, there is potential for wave energy that is reasonably high